Welcome back, smart mathematicians. Let's do question 12A3. The 5 cards given below are used by players in a game to create 5-digit codes. A few examples of 5-digit codes that can be created with the cards alongside are, we have these examples here. No repetition is allowed. What is the probability that the two letters will never be next to each other in the code? So it may be difficult to find this probability, and if you check, it is easier to find the probability when the two letters are next to each other. And then when we get that probability, then we subtract it from 1. Okay, because these are what? Complementary events, since they are mutually exclusive and exhaustive. Now, let me give you an example. Let's say if the probability of it raining today is 0.6, what is the probability of it not raining? The probability of it not raining should be equal to 1 minus 0.6, which is 0.4. So if the probability of it raining is 60%, so it means the probability of it not raining is 40%. So now we'll find the probability when the letters are next to each other. And then how do you find the probabilities if the two letters will never be next to each other? We subtract that probability we get from 1. Let's say probability of letters together. So what do we say? We're saying these are moving together now. They become a unit. You see that? They become a unit. So the arrangement within this unit, there are 2 items in this unit. So the arrangement within this unit is 2 factorial. What about the arrangement between these 4 units now? Because this one, the 2 factorial is for arrangement within the unit. Let me just put it like this. This is the unit we're talking about, because they are moving together, isn't it? It's one unit. So within the unit, the arrangement is 2 factorial. It can be AB or BA. We have how many units now we're looking at? We have 1, 2, 3, 4. So we're looking at the arrangement now of these 4 units, which is what? Which is 4 factorial. 4 factorial. The first position, we have 4 choices. The second one, we have, let me just draw here. There are 4 units, including the one with AB there is a unit. We treat like a unit. So there are 4 units. So the first position, we have 4 choices. The second position, we have 3 choices. The third position, we have 2 choices. And then the fourth position, we have 1 choice. We're treating this whole thing AB as a unit. So it means this is 4 factorial. So it's going to be 2 factorial times 4 factorial. This is the number of possible arrangements if the letters are together. But we're asked to find probability. So it must be, so here we're finding probability. And remember that the total possible arrangements, we got that when we're doing question 12A1. It is 5 factorial. So this will be 2 factorial times 4 factorial over 5 factorial. Okay. And then this will be, right, 2 factorial times 4 factorial, that is 48. 48 over 125 factorial is 120. And then 48 divided by 120 is 0.4. Right. But remember, this is the probability of letters being together. But we want the probability that the 2 letters will never be next to each other. So what do we do? So probability that letters will never be next to each other is equal to 1 minus 0.4, which is 0.6. Probability that letters will never be next to each other, 1 minus 0.4, which is 0.6. We'll meet when we do question 12b.